Okay, we're back in the shop and now we're going to machine the roughed out slot in our sine base to fit our small grinding vise. So let's begin. I roughed it out. I left it about 5/10 of a millimeter on both sides heavy, and now I'm taking a skim cut, then I measure it and then I'm going to adjust my cut. And I went a bit deeper than the actual surface will be later to give it some relief in the corners. And I'm using again my handy disc mic to measure this step. I really like this mic. With a normal standard mic, it's hard to get such a shallow step. And with the discs protruding of the mic itself, you can get around that very easy and get a pretty accurate measuring, and I'm at 5.31 millimeters. Target is 5.08. I set up one of my dial indicators to get an exact reading of my travel, and I need to step over 0.22 millimeters, and with the dial indicator that's very easy to get. Okay, that's our 0.22 millimeters. Now it should be the finishing cut right now. Okay. Now we take our measurement. And we hit our 5.08 millimeters. Now we go over to the other side and finish this side also to width. Okay, I'm not actually going to measure this side because I'm interested in the width of the slot. Taking a rough measurement with the dial calipers or digital calipers, and I'm 24.33. Target is 24.88 as a close fit. I measured this with the digital mics and it's 24.88. So we need to widen the slot by about 5/10 of a millimeter. I'm going with a cut of 4/10 of a millimeter, then I'm going to check the width with gauge blocks, and then I'm doing my final cut. Okay, now we have 24.7 and a few. This gauge block stack is actually 24.72 millimeters. So let's see if it fits. Okay, this goes in very nice. It's a bit loose. I will try 24.73. That's a nice close fit. That's what I want. no wiggle, and just a nice fit. So this gauge block stack is 24.73 millimeters. My target is 24.88, so 24.88 minus 24.73 is 0.15 millimeters. I need to cut another 15 hundredths of a millimeter wider. Actually, I will give it 14 hundredths of a millimeter, so I have to have some room left to hand fit the vise into the slot. Bring our tool down. I could do this on a milling machine without a problem, but I find it much easier on the shaper. On the milling machine you always have to deal with cutter deflection and the fact that the end mills wear down on the bottom and stuff like that, and in the shaper you're just single pointing and you don't have any of these problems. It's just a matter of accurate measuring and setting your machine. And that's a very nice fit for my small vise in the slot. There is no wiggle at all, but it's going in very nice. And yeah, that's it. That's a nice fit. Now we're going to rotate the vise by 90 degrees. No, first we're going to finish up the bottom of this slot, and then we're going to rotate the part by 90 degrees and cut the crosswise slot. Okay, we're finishing the bottom surface. Okay. And I was just hand feeding across the bottom. Actually, this slotting tool with its wide cutting edge gives a pretty good surface when you're finishing across a surface. And again, the small vise fits in very snugly. Actually, it just bound up on me. I will have to deburr the slot and do some hand fitting because it's a bit tight, but better tight than loose. We're going to turn this vise by 90 degrees, align it, and then we're going to cut the slot in the other direction. I'm rough aligning it with the dial down here on the vise, but I'm also going to dial it in with my thousandths indicator. The needle jumping, this is some of the surface roughness on there, because this indicator is really sensitive, but as you can see, it averages out between 20 and 30, so this is well under 1/100th of a millimeter. Okay, here we are at 24, and if I crank it to the other side, we are at 24 also, so this part is straight in the vise. Okay, I started to cut these, to rough out the slot, and I did my first cut. Now I'm setting over for the next one, and this is an interrupted cut. That's on a shaper always a bit, you have to be careful not to advance the cutter between the two engagements of the cutter, or you will have a problem. Okay. I cut the cross slot a bit deeper than this surface, because getting those two to match up exactly at the same height is almost impossible, so I'm just pulling this surface a bit deeper. It won't matter in that direction, and also in that direction it's I'm only down 5/100ths of a millimeter, and for finishing I'm going down another 500, so I'm 1/10 of a millimeter deeper on the cross slot than on the lengthwise slot. Okay, let's go for the finish cut. Bringing our cutter down. Okay, that should be our finishing cut. And we do a test fit with the vise. Let's crank this over so I can. Yep, that's a good fit. Okay, let's finish the bottom of the slot. Now the cross slot is also finished, and we can remove the part from the shaper. Okay, now as we have the slot cut in for the vise to go in, this and that direction, we actually need to drill the holes for the hold downs of the vise that will clamp down the vise, and also we have to make the clamps, but first we will drill these 4 holes. Okay, for centering up in the slot, I'm using the dial test indicator and I'm just swirling it between the two pieces. And X is also on center. Okay, that was spot drilling. Now we're going for a 2.5mm drill for a 3mm tap. And for that we're going to use some cutting oil. Just some cutting oil, and all four. And I have to say, power tapping is one of the coolest things ever. The chances of breaking a tap or getting a crooked or off-angle thread are very limited. The only reason a tap will break while power tapping is because it's getting dull, it binds up on the material, or you bottom it out on the ground of the hole if it's not a through hole. So be sure to drill the tap hole at least 1 times the diameter deeper than the actual thread depth. And also use cutting oil, and don't blame me if you break a tap while power threading. But it sure beats using a tap follower. I hate those things. I hate hand tapping. Okay, next thing we will put in here is are in fact the holes for the pins, for the alignment pins. There will be one here in the center, 2 on the opposing ends, and 1 down here. And I will show you what's the idea behind that. Okay, you're now at eye level with me, and we're looking at the unfinished sine base with the sketched out pin location. And now bear with me. Think you put a 6mm dowel pin in here and in here. That sticks out. Okay? Now we're going to drop this in the vise, and both pins sit on top of your vise jaw. Of course, because we aligned everything before we drilled it, now the top surface will be leveled. But we can put a gauge block under one of the pins, clamp it, and that way we can set this vise to very accurate angular settings. In fact, that's, to my mind, that's the most precise way to set an angle in the shop. The guys that run surface grinders use sine bars, the jig boring and jig grinding guys use sine bar setups. Even some of the milling machine machinists that run milling machines all the time use sine bars. I use a sine bar to set my compound slide on a lathe, and it's pretty easy to calculate. You need your distance between the two pins. In this case we will go for 60 millimeters. And you need your angle. So you go, now we want this to set at 30 degrees. You go 30 sinus multiplied by 60, that's the distance between the pins, and you need 30 millimeters of stack up here. Now if we think of this is a 30 millimeter gauge block, you put it under one pin, the other pin sits on your vise, and this are exactly 30 degrees. So this is the long setting. We can also put a pin in here and in here. Then we have 30 millimeters of sine length. I can tilt it in by setting gauge blocks here. And now imagine there's the small grinding vise. With this contraption you can reach pretty much any angle possible. You can even tilt it that way. Even a shop-made sine bar can be very accurate, as the only important thing is the distance between the two pins, and you can measure this very precise with micrometers. So we're going to drill and ream these 4 holes to accept 6 millimeter dowel pins. I'm going for the dowel pins because they are hardened and ground and just accurate all around. So that's okay. I set up the part in the vise and I checked it with the 2000 indicator in every direction if it's flat and level and square to the machine, and now I need to center it, and the only feature that can be centered is the shallow slot in the top. But there is not enough room to get in with a edge finder or even with the dial test indicator. So I'm using a gauge block stack up that fits into the slot, and now I can touch off on both sides with my edge finder. Okay, we're going to center drill our holes, or spot drill. We will check our hole layout with the scale, just to prevent any bozo move. We have 60 millimeters from here to here, and we have 30 millimeters from here to here, here to here, and down here. So that's fine. Something. shop, a drill bit is a roughing tool. It's an absolute roughing tool. It's just there to hog out material. If I want to get fancy, I can still bore or ream the hole. But standard drill bit, in my mind, is only good for hogging. Now we're going to step up this hole to 4.6 millimeters. And now comes the first step that gives us some precision. We're going to use a end mill and plunge into these holes. I'm going to use this 4-flute 5mm carbide end mill. It's a bullnose. It has a small radius on the corner, so it will take the plunge pretty good. Now I can be pretty sure that my positions of the bores is pretty accurate. This machine has gas scales and it positions slightly better than 1/100th of a millimeter, so this is good enough for me. Even a slight variance in the hole distance, it will not give that much of an angular error. So now we are at 5 millimeters, but we're going for a 6mm bore, and that's a bit much material to ream out. So I just found a resharpened 2-flute carbide end mill, and that's 5.77 millimeters in diameter. 5.77, around that, and that will leave me just enough material for reaming. So now we're going to use this end mill and open up. Okay, there we go again with the 5.77 millimeters end mill. Okay, and this end mill just opened up the hole to 5.75 millimeters, and that's almost perfect for reaming. And also I can be sure that my position is still spot. It wouldn't have been a disaster, but I don't like reaming without a nice chamfer. That's the reamer. There's our reamer, and what we're going to do is we're not going to bottom it out in the stepped hole, because if you do that, the hole goes instantaneous oversize. There's no way around it. Bottom a reamer out and you're done. You made a nice oversized hole. And what we want here is just a nice sliding fit. So let's get the chips out of the way. And I stepped drilled down 15 millimeters, and now we're going to ream About 12 millimeters. That will give enough space for the chips to go. Plenty of cutting oil. Okay, 12 millimeters. I'm just going to check our fit with a dowel pin. That's the fit I wanted. If you're using cutting oil, the arima actually cuts slightly bigger. If you're using a thinner medium like soluble oil or another water-based lubricant or cooling fluid, the hole gets tighter. But as these pins will need to go in and out all the time, I like this fit. This is good. Okay, now we have the pinholes drilled and we can actually check if we got our positions right. These are a pretty nice fit and I'm very happy how this came out. So also the device itself sits pretty tight. That was the movable chart chest. The device sits also pretty tight in the slot, and now I can measure from here to here if we got our 60 millimeters, and from here to here, here to here, and here to here if we got 30 millimeters. So I have my 50 to 75 Mauser micrometer. And I'm taking my measurement. And we have 66 point, yeah, half a hundredth of a millimeter over. So that's pretty damn good for holes drilled on a milling machine. Especially as these are drilled and reamed, not really bored. Yeah, this is consistent. Now we change our pins from here to here, and now we have to go with the crappy 25 to 50 millimeter Chinese micrometer, and we take our measurement again. As I said, the distance between the pins is 30 millimeters. Of course, when we take our measurement, we have to add 2 times half the diameter of the pins, so we will actually measure 36 millimeters. Yeah, and we are just a hair under 36 millimeters. Just a hair under. And move this pin over. With that one we are not even a hair over, it's half a hair over. And last possible position, we have this here. Okay, here we are 1/100th of a millimeter under. That's not perfect, but I can live with that. If I know that I'm off, it doesn't matter really. I have to take it in account when I do my the math for the gauge block stack up. So, and now I'm going to show you how this will actually look in when in use. Just put the movable jaw on, so you again I take in my grinding vise, or one of my grinding vices, and say you want this to be angled. You do your math for your gauge block stack up, and then you put your the jaws on this vise are not high enough to support the pins on the jaws. It will bottom out in the vise before, so you would have to add, say, 5mm to both stack ups just to lift it up. And as this is just a demonstration, you can see what I mean. Now you have a small vise tilted by a very precise manner. You can calculate this stack up very exact, and as gauge blocks are very precise, you will get a pretty precise angle with this setup. And what you can also do, you can put one pin over here and one in here. Then you can hang the vise in like this, and you can go over 90 degrees even. You can exchange both your gauge blocks. Then you can tilt it over even further. I don't know for what you would use this extreme angle, but it's possible. You can do it, and I just realized that when you put one pin in here and here, you automatically get 45 degrees. Say you want to machine a chamfer on a part and you don't want to do the gauge block stack up, you put just a pin in here and in here, drop it in, and you got a 45. So you see, this is going to be a very versatile small vise. Heck, you could even use it on a angle plate. Of course, you would have to do this on a surface plate. You set it up with the gauge blocks in front here, push them in, and then you need to clamp the sine base against your angle plate, and then you can set up on your angle plate, and you can use it on the surface plate, and I think this is going to be pretty versatile. So next time we're going to cut the circular shape of this thing, and we're going to engrave the dial. I want a dial here, so if you put a pin in the center and imagine that this is your this is a fixed jaw of a vise, and then you can say you have your dial here, and then you can actually just by eye set your angle if it's not a precision application. And also we need to make the strap clamps that hold the vise in place and make it pretty. Just chamfer all the edges and I also want to thread these holes to push out the pins if they get stuck for some or another reason. Maybe there gets coolant in and the pin gets stuck, so you can push it out with a screw from the back. So that's the stuff that's left to be done. Hope you enjoyed this episode and thank you for watching. See you next time.